Hello students, welcome to Abdemi's online platform. I'll be discussing a problem on vector analysis. So let us see what that problem is. So this problem, see the statement of the problem. It is let vector u, vector v, vector w, notation, we are familiar with this notation, but of vector, but sometimes we write this also to represent a vector u. So let vector u, vector v and vector w are in three-dimensional space where u, v are unit vectors. That means mod u is unity, similarly mod v is also unity. And they are not perpendicular to each other. That means u dot v is not equal to 0. Okay. Because they are not perpendicular, that means the angle between these two vectors is not 90 degrees. So therefore cos 90 is 0, if they are perpendicular. And since magnitude of u and v are unity, so u dot v is not equal to 0. This is given. And u dot w, vector u dot vector w equal to unity, vector v dot vector w is unity, and vector w dot vector w is 4. Okay. U here unit vector, w is not unit vector, that's why w dot w is 4. Unity u and v are unit vector means u dot u is also 1 and v dot v is also 1. I will be using the arrow overhead, the symbol. Okay, though in the question it is underscore, it is written like v, but this is nothing but v vector. Same notation, same thing you can say. If the volume of the parallelepiped whose adjacent sides are represented by vectors u, v and w is root 2. That means u, v, this is u vector, this is v vector, and this is another vector w. So volume of the parallelepiped formed by these three vectors is something like this. So this vector is w vector, this is v vector, u vector or v vector, and this is u vector. So this it is nothing but u dot v cross w. Box product of these three vectors, it is said to be root 2. U dot v cross w is root 2. Then we have to find the value of vector modulus of the vector 3u plus 5v. How much is this? That is the question. So u, v and w are three vectors in 3 dimensions, where u and v are unit vectors. The mod u and mod v are unity. That means u dot u is unity, v dot v is also unity, and they are not perpendicular to each other. U and v, this angle is not 90 degree, and therefore u dot v is not equal to 0. Okay. And u dot w equal to 1, v dot w is equal to 1, and w dot w is equal to 4. If the volume of parallelepiped whose adjacent sides are represented by the vectors u, v and w is root 2, that means a parallelepiped like this, and volume of a parallelepiped formed by three vectors u, v, w, it is u dot v cross w, or it can be written as v dot u cross w, or it can be written as w dot u cross v, whatever. So this is the volume of parallelepiped and this is equal to root 2. Then you have to find out the value of mod 3u plus 5v. Okay, this is the given problem. Now, one thing before we solve this problem, let us recall one important thing, a property of determinant. What is that? You know, if I consider this as a determinant delta as A1, B1, A1, B1, C1, A2, B2, C2, A3, B3, C3, then you know it is nothing but A1 multiplied by B2, C3 minus C2, B3 plus B1, C2, A3 minus A2, C3 plus C1 multiplied by A2, B3 minus B2, A3. That you know. And let us consider another determinant delta dashed, which is actually transpose of this determinant. That means the first row has become first column, A1, B1, C1. Second row has become second column, A2, B2, C2. And third row has become third column, A3, B3, C3. Okay, so it is transpose, delta dashed is transpose of the determinant delta. Okay, so delta dashed is basically delta t, transpose of the determinant. Now, what is the value of this determinant delta dashed or delta t? Is nothing but A1 B2 C3 minus C2 B3 plus A2 C1 B3 minus B1 C3 plus A3 B1 C2 minus C1 B2. So it is, I keep this term as it is, A1 B2 C3 minus C2 B3 plus, if I write B1 C2 A3 minus A2 C3, I can write, because I have taken this particular term and this particular term and taken B1 common, therefore A3 C2 minus A2 C3, and then there are remaining terms, two terms, from that I take common C1. So this term, you can say, this term and this term, if I write, and if I take C1 common, then it is A2 B3 minus B2 A3. So what is this? This term, these two terms are identical, A1 B2 C3 minus C2 B3 plus B1 C2 A3 minus A2 C3, and this term C1 A2 B3 minus B2 A3. Therefore, it is equal to delta. Therefore, if rows and columns, rows of a determinant, it is a 3 by 3 determinant, third order determinant, it is also third order determinant. If the rows and columns are interchanged, then the value of the determinant remains unchanged. That property you know, just we recapitulated this thing. Okay, this is one property. Just remember the determinant of A and determinant of AT, they are equal. A is a 3 by 3 matrix, is transpose determinant of this, that is delta, is equal to delta T. That property we have discussed. Another thing, just recall, if two matrices, say 3 by 3 matrix, one matrix is, say for example, A is A1, B1, C1, A2, B2, C2, and A3, B3, C3, and another matrix B is L1, M1, N1, L2, M2, N2, L3, M3, N3. Then C is another matrix A, B. Then determinant of C is equal to determinant of A into determinant of B. That property, that is also an important property of matrices. CAB 3 by 3 matrices. Okay. Now A into B, C, matrix C, which is the product of these two matrices A and B, is actually what? A1, B1, C1, A2, B2, C2, A3, B3, C3 multiplied by the matrix L1, M1, N1, L2, M2, N2, L3, M3, N3. So it is row by column multiplication principle, you know. So the first row, first element of the matrix C will be A1 L1 plus B1 L2 plus C1 L3. First row multiplied by first column. So this is the first row, first column element. A1 L1 plus B1 L2 plus C1 L3. First row, second column of C will become A1 M1 plus B1 M2 plus C1 M3. Okay, B1 first row, second column, A1 M1, B1 M2, C1 M3, and first row, third column will be A1 N1 plus B1 N2 plus C1 N3. And in a similar manner, say for example, the matrix elements can be calculated. That means second row, first column will be this A2 L1 plus B2 L2 plus C2 L3. Second row, second column will be A2 M1 plus B2 M2 plus C2 M3. And second row, third column will be A2 M1 plus B2 N2 plus C2 N3. Third row, first column is A3 L1 plus B3 L2 plus C3 L3. Third row, second column, A3 B3M1 plus B3M2 plus C3M3. And third row, third column will be how much? Let me write the third row, third column element for an example illustration. So it will be third row, third column, it will be A3N1 plus B3N2 plus C3N3. So this is the way the matrix multiplication can be carried out, and therefore determinant of this, that means if I take determinant of C will be determinant of A multiplied by determinant of B. Okay, whatever I have written. That means if I make the two determinants, date A is how much? Date A, these are matrices. Date A is actually, this is the determinant. A1, B1, C1, A2, B2, C2, A3, B3, C3. And determinant of B is how much? Simply this determinant L1, M1, N1, L2, M2, N2 and L3, M3, L3, M3, N3. Then the product of these two determinants, if it is called C, then C is, this is determinant of C will be determinant of this matrix. Okay, so I can write determinant of C as this one. Determinant of C will look like this determinant. The first row, first element will be A1, L1 plus B1, L2 plus C1, L3. Second, first row, second column is A1, M1 plus B1, M2 plus C1, M3. And first row, third column element will be A1, N1 plus B1, N2 plus C1, N3. Something like that. In that manner, the product of two determinants can be found out. So, with this background, let us proceed to the problem. Okay. Now, what's the problem? Let us try to solve the problem. Now, it is given that U dot V cross W is equal to √2. Now you know U dot V cross W. Let me first write V cross W. V cross W I can write it is I, J, K, Vx, Vy, Vz, Wx, Wy, Wz. I can write. What we have done over here, I have assumed that vector U is actually Ux I cap plus Uy j cap plus Uz k cap. Similarly, V vector I have assumed it is Vx I cap plus Vy j cap plus Vz k cap. And W I have assumed Wx I cap plus Wy j cap plus Wz k cap. And I, J, K are unit vectors along X, Y and Z axis respectively. Okay, so this you have assumed. So with this background, if I evaluate this, is how much it is I cap Vy Wz minus Wy Vz Wy Vz plus J cap Vz Wx Vz minus Vx Wz plus K cap Vx Wy minus Wy Vx Vx Wy minus Wx Vy. Okay, and therefore U dot V cross W is equal to how much? This is nothing but Ux Vy Wx my Vy Wz, sorry, Vy Wz minus Wy Vz plus Uy Wx Vz minus Vx Wz plus Uz Vx Wy minus Wx Vy. So I can write from this, I can write this is nothing but the determinant Ux, Uy, Uz Vx, Vy, Vz Wx, Wy, Wz. So U dot V cross W I can write as equal to this. This you know, but just we discussed for sake of completion of our discussion, that you know. So let me write over here U dot V cross W is equal to Ux, Uy, Uz, Vx, Vy, Vz, Wx, Wy, Wz. Okay, now I can write this as, if I just interchange the rows by the corresponding columns, then I can also write these as Ux, Vx, Wx, Uy, Vy, Wy and Uz, Vz, Wz. Because we have just learned that both the transpose of a determinant is equal to the determinant itself. So I can write this thing, these two are equal. Alright, now it is equal to root 2. Alright, now if I take the square of this, what happens? That means if I write u dot v cross w multiplied by the same thing, if I take square of this, then it is nothing but what? Square product of these two determinants. I can write ux, so this is how much? This is, I can write ux, uy, uz, vx, vy, vz, wx, wy, wz multiplied by this determinant, which is ux, vx, wx, ux, vx, wx, uy, vy, wy, uz, vz, wz. So what I can do? Product I can write like this. So first term is ux, vx, ux into ux, or it is ux square I can write. So let me write this as ux square plus uy square plus uz square. This is the first row, first column element. First row, second column is what? Ux, vx plus uy, vy plus uz, vz. Then first row, third column of this determinant, resultant determinant, is actually ux, wx plus uy, wy plus uz, wz. Okay. Then second row, first column is actually ux, vx plus uy, vy plus uz, vz. Is it okay? This into this, ux, vx plus uy, vy plus uz, vz. Second row, second column is actually, you see, it is vx square plus vy square plus vz square. It's not difficult, very simple. And second row, third column is actually vx, wx plus vy, wy plus vz, wz. And then third row, first column is actually how much? ux, wx plus uy, wy plus uz, wz. Then third row, second column is actually vx, wx plus vy, wy plus vz, wz. And finally, third row, third column of the resultant matrix determinant, product determinant, is actually Wx square plus Wy square plus Wz square. So this, when I write this determinant, that means the square of this, that means this into this. While taking product, I have just rearranged the rows and columns, just taken the transpose. So what is this? This is nothing but the first row, first column element is actually u dot u. Then it is u dot v. Because this is ux vx plus uy vy plus uz vz. So it is u dot v. And here it is u dot w. And then this element is u dot v again. Plus v dot v. And here it is v dot w. And then here it is u dot w plus v dot w. Here third row, second column is v dot w, and here it is w dot w. So this is the determinant. Now what is given? It is given, what is given? We know that u, v are unit vectors. So u dot u is unity, v dot v is also unity, and it is also given w dot w is 4, and u dot, and what is also given that u, v are not perpendicular to each other, and u dot v, it is not given. So let u dot v be x. Let say u dot v is x. Okay. Now from this, what we can, if I substitute these values over there, then what we get? So u dot u is unity. So I write this as unity. U dot v, I have taken this as x. And u dot w is how much? U dot w is unity. It is also given u dot w is unity. And v dot w is also unity. So if I use this given data in this computation, so u dot w is unity, u dot v is x, I have assumed, so I write it x. V dot v is unity, so I write it 1. And v dot w is also unity, it is given like this. And u dot w is unity, again v dot w is unity, and w dot w, it is given as 4. So u dot u, just let me cross check, u dot u is unity, u dot v I have taken as x, and u dot w, it is unity. U dot v I have taken x, v dot v is unity, and v dot w is 1. And u dot w is unity, v dot w is unity, and w dot w is 4. So what is the value of this determinant? Is actually 1, 4 minus 1 plus x, 1, 4 x1 minus x plus 1 x minus 1. Okay, so 1 4 minus 1 plus x1 minus 4x. It is not x. So x1 minus 4x plus 1 x minus 1. So how much is this value? So it is 3 plus x minus 4x square plus x minus 1. So it is how much? So 2 plus 2x minus 4x square. So this is how much? This is equal to, this thing is root 2 square, because u dot v cross w is given as volume of the parallelepiped, it is given as root 2. So this is actually nothing but root 2 whole square. So that is 2. So it is equal to 2. So 2 plus 2x minus 4x square is equal to 2. And therefore, I can write 2x minus 4x square. 2x minus 4x square is equal to 0. Or 2x, if I take common, 1 minus 2x is equal to 0. Okay, therefore either x equal to 0 or 2x equal to 1, that is x equal to half. So I get two solutions, x equal to 0 and x equal to half. So x equal to 0 means x is how much? X, I have taken this thing, u dot v equal to x, but u dot v is x. But u and v, they are not perpendicular to each other, therefore u dot v equal to 0. This cannot be a possible solution. So u dot v has to be equal to half. So this is the acceptable solution. So acceptable solution, acceptable value of x is half, x equal to half. So if x equal to half, then what happens actually? What I find is that u dot v is x, which is nothing but half. Okay, so we have found like this. Now let us further proceed. So far I think you have understood what we did. Okay, now we have to find the magnitude of one vector, which is, vector is how much? 3u plus 5v. So 3u plus 5v vector's magnitude I have to find out. So what I do? So I construct a vector, say for example f vector. If I call this vector as f vector, then vector f is actually how much? Say let vector f is 3u plus 5v. Okay, so it is mod of f is actually mod of 3u plus 5v. Okay, so if I calculate f dot f, which is nothing but mod f whole square, is how much? It is actually 9 u dot u plus 25 v dot v plus 2 into 3 into u dot v. Okay, so u dot u, I know it is 1, so it is 9 plus v dot v is also 1, so plus 25 plus 30 u dot v. U dot v I have found half. So it is how much? 34 plus 15, which is 49. Therefore, mod f square is 49. So mod vector f is 7, but mod vector f is actually mod 3u plus 5b is equal to 7. Therefore, the solution of this problem is 7. The answer is basically 7. This is the answer. Answer is 7. So, very interesting problem. Many properties of determinant matrices are used over here. I have explained all the steps, which properties are to be used, and you have already shown how to prove those properties. And using those properties, we could solve this problem. I found this problem very interesting. Some of you have asked me to requested Abdemi to work out this problem for online class. That's why I picked up this problem, and I find really this problem is interesting, and I think you have found it useful. Thank you very much for your listening. Thank you.